Afternoon. Good afternoon, everybody. It's 5 o'clock on Tuesday, which means it's time for math. My name is Jeremy Jasper with KathleenJasper.com. And for the next hour, we're going to do all things math for your teacher certification exams. So thanks again for joining me on another session. We're here live every Tuesday from 5 to 6 p.m. And if you can't catch me live, we record this and we put it on our YouTube channel, and you're able to stream it and rewatch it whenever you like. We have plenty of sessions in our channel, so you can go back as far as, I think we've been doing this for almost a year now. And so every week is 10 questions that are kind of generic questions you'll see on a teacher certification exam. I try and highlight as many competencies and test specifications that I can. It's not specific to any one test. That's the biggest question. Is this for this type of test? Is this for another test? No, it's not. It's just to understand math, understand taking certification exams, little tips and tricks here and there, and then just kind of reinforcing some of those skills that are necessary to be successful on your math certification exams. So we're going to get right to it, and I'm going to go ahead and make sure I'm live on all of my platforms. If you're on Facebook, then please go ahead, comment in the comment section below. If you have any questions at any point in time during the session, and then the same thing goes for YouTube, go ahead and comment below, and I will try and get on it in real time, or at least at the end of the session. Sometimes I just get going and I can't really remember to check, and then all of a sudden there's a whole bunch of comments. So go ahead and leave your comments, and then if you're watching this on the restream, by all means, please feel free to email info@KathleenJasper.com, or just put it in the comments. We see all the comments, and I can go ahead and answer that accordingly. Okay, let's go ahead and just jump right in. I hope everybody is having a good, already into the second week of August, which is kind of crazy. Some of you are already in, some of you are already in your classrooms, whether it's for real or you are in preschool week. But, you know, the beginning of the year is hectic as always. So make sure, if you still need to take your certification exams, find a window where you're able to do that and not really, you know, put your certification in jeopardy by having so much work at school that you're not able to study, or vice versa. All right, so you got your scratch paper, you got your calculator. Again, make sure you've always got a calculator to work with. Check your tests that you're taking, and in the specs, it'll tell you what calculator you are allowed to use. And then was there anything else? I don't think so at the moment. So let's go ahead and jump right into it. Problem 1 says, which of the following statements is true about the numbers in list L? So here's list L, and it's up here. Oh, that was the thing I was going to say. In both Facebook and YouTube, you'll see that the link has all of these problems. There's 10 problems. They're all laid out on their own individual sheet of paper, so that you have the problem and then you have the space underneath to work as your scratch paper. So that's what you have to do, because you got to imagine that the top part is going to be what's on the computer. You're only allowed to write in the blank spot, and you've got to be able to get all that information down that you need in order to solve the problem, and then make sure you get all the numbers right, and so on and so forth. But it's just a way to practice, because time management is key, and that's another part of being successful on these exams. So we have list L, and what do we do when we're looking for mean, median, mode, all that stuff? We call them measures of central tendency. Looking at the answer choices, they're comparing. It says the mean, the mean, the mean, the mean. There are a couple ways to go about this, and it's all about how comfortable you feel with doing mean, median, mode, and so on. The first thing you want to do, if you can't look at it and see which order they're in, go ahead and order them. Always order them in ascending order. That means low to high, but you got to make sure you get the numbers right. And this is where it gets tricky. And you need to, I know it sounds silly, but you need to practice this where you're looking at a screen or you're putting this problem up in front of you, and then you have to look down to look at the numbers. Because it's easy, if I look at this and I'm looking at a piece of paper, I can just look at the numbers, but you have to look up to look down, look up to look down, and practice that, because during the test, that's what you're going to have to do because you're looking at a computer. So I can't stress this enough, and that's why I talk about this every single session. Be comfortable using scratch paper and a scratch pad, writing down only what you need to write down, looking at the screen using your calculator and just doing everything in the calculator. All these things are going to help you with time and getting and being more efficient at this test. It looks like we need to find the mean straight up. So when we want to put these in ascending order, I'm looking, I got 64, 81, 96. I look at the first number. So I see 6, 6, 8, 9, 7, 9, 8, 7, 9. So 6. So the 60s are going to be my first one. So I'll just go 60s, 70s, 80s, and so on. So 64 and 69. So I know I've got 64 and then I've got 69. That's it for the 60s, right? See, I can't cross this out, and you can't cross it out, and you shouldn't cross it out because you're not allowed to, because it's going to be on a computer screen. So it's not, those are the little things you need to be aware of. Next to the 70s, I see a 77 and 71. So 71, 77. And then after the 70s, I see 80s. I see 81, 81, 81, 81. Nothing left. Then go to 90s. I see 93. And I see 96. So I'm going to count up. I got 1, 2, 3, 4, 5, 6, 7, 8. I'll count up here. 1, 2, 3, 4, 5, 6, 7, 8. Doesn't look like I missed any numbers. Now, when I look at this, I'm going to say to myself, well, what's the mean? You can kind of see that the mean is, because of the way that they're distributed, is going to be in this area here. So maybe mid to high 70s, low 80s. Okay, would be my guess right off the top. And if I want to go where it says mode, or if I'm looking mean is the same equal to mode, well, the mode is 81. So that's pretty close. I can't just really guess that. B says numbers, the mean is greater than the mode. Well, if 81 is the mode, the mean may not be. It looks a little high. Mean is equal to the median. I don't know about that. And then mean of the numbers in list L is greater than the mean. Okay, so a lot of mean and median. So that's what I'm going to find. I'm going to find the median and I'm going to find the mean. We just want to try and get this done. You don't need to find mean, median, mode, and range, because sometimes you see these and automatically you just go through all 4 of them. Only do as much work as you need. I usually leave mean for last, but in this case, we just have to find it. So if I were you taking the test, I'd pick up my calculator because I've got my numbers listed. And with my numbers listed, at least I can look at that now. And I can say to myself, okay, let's add them all up. So I go 64, 69, and I end up with 632. So 632. So it's in my calculator. So I'm writing it down so you can see it. But what I want you to do is I want you to be comfortable enough to be in your calculator, add them all up. You get 632. 632 is in your window. There are 8 numbers, right? I've got to take the sum of all and then divide by the amount, or the number of numbers there are, the number in the data set. And it's 8. So I just hit divide 8 in the calculator. So really, without writing this part down, which was this part here, everything's in the calculator. So you just go 79, boom. So 79 is the mean. So now let's go to mode, because the first 2 answer choices have mode. Well, 81 is the mode. So this is the mode. The mean of the numbers in list L is equal to the mode. Is 79 equal to 81? Nope. So that doesn't work. The mean of the numbers in list L is greater than the mode. Well, the mean is 79, mode is 81. Nope, not going to work. The mean of the numbers in list L is equal to the median. Okay, now I've got the median. Well, how do we find the median? Because the mode is gone. I've already taken care of that. There are 8 numbers, 1, 2, 3, 4, 5, 6, 7, 8. If I were to go down, the 2 middle numbers, okay, are numbers 4 and 5. So because it's an even numbered set, these 2 middle numbers, we have to find the average of the 2. So I've got 77 plus 81 divided by 2. Again, I don't need to write that down because I've got my calculator. So I would just do 77 plus 81 equals, divide 2 equals, look at that, it's 79. So the mode is 79. C says the mean of the numbers in list L is equal to the median. 79 does equal 79. That is correct. D says the mean of the numbers is greater. Well, 79 is not greater. Again, just to double check. And that's how we do that problem. It's just, you're going to have to do it. Get comfortable with your calculator. Okay, very important. Just get comfortable. Your calculator should really be in your left hand or your right hand the entire time. And then you're just clicking away, doing some work on the scratch paper and those kind of things. All right. Okay. Question number 2. The table below shows the hourly pay for the employees of Riverview Community Bank. Okay, there's our pay schedule, president, secretary, all the listing, and then their hourly pay. Which statistic is most representative of the hourly pay of the employees? What does it mean to be the most representative? Now, the most representative would be, okay, if I were to get a job at this company, what should I expect to be paid? Like, what is a reasonable salary or a reasonable hourly pay to be paid? Obviously, you're not going to get the highest paying job. Like, that is not a representation of what it is. So you see that most of these, the range goes from $825 to $185. So obviously you're going to want to be between there. But when we talk about these, I want to focus on this specifically. This $185 is an outlier. That is way too much. That is never going to be representative of what a company pays unless all of these salaries are right around $180, give or take, like, even $20, $30 each. Okay. So what are we going to use in this case with mean, median, mode, and range that they give us to show the greatest representation? So let's go through it, and let's go through easy. So out of all 4 of these, I would rank these from easiest to hardest. I would say the mode is first, then the range, then the median, then the mean. And when I say easiest, I mean, degree of difficulty for as much work as you have to put into it. So mode would be first, and mode is the most. And you can see that 825 happens twice, and it's the only one that repeats itself. So mode being 825. And I look at 825 and I see those are the 2 bottom numbers. Is that representative of what you would get paid? And usually the top and the bottom numbers are never representative of what you would get paid as an hourly employee at this company, or just in general, right? That's why they're the highest and the lowest. So I'm going to go ahead and I'm going to eliminate that. The next one is range. And why is it range? Some would say range is easier than mode. I only say that because mode, you just have to look at it. Range, you actually do have to do the operation, but it's just subtraction and it's not that difficult. And even if I say to myself, well, it's 185 minus 825, that's such a high number anyway. That 825 is almost irrelevant to take away from the 185, and it's never going to change anything. Just so you can see it, 185, well, that is a 185. Minus 825, because range is high and low. 185 minus 825. I got $176.75. So going into this job, would you expect to get paid $176? No, absolutely not. So that's going to be gone as well. Now, I know I'm kind of over explaining this, and some people are like, well, I can already see which one it is, but that's why I'm doing it, because I want you to be able to go through the motions and understand this type of question. The next one would be median. And again, I've got 6 values. So with an even numbered set, right, there are 6 values here. I take the 2 middle ones. So then we add those together. And again, all this can be done in your calculator. You really don't have to write anything down. Plus 975. So these two equal 24 divided by 2 equals 12. So is $12 representative of what you might get paid? So see how 12 kind of does a nice little rate kind of in the middle of all of these 5 salaries. So I like that pay, or hourly pay. I like that as a representation because it's not too high and it's not too low. The mean, and then this is where your understanding of the mean or the average comes into play. Because this 185 is such an outlier, it's going to drag all of the, all of the weight or all of the value towards that high number. So even though these two 825s, the 9, the 14, and 21, when you take the average, it's going to be some really high number. And I did the average, and it comes out to 227. Just knowing that that number is so high, just know that the mean is, there's no way the mean is gonna happen. But if you add it all up, it's 227.50, and then you have 6 values, and it's going to be 37.91. So is 37.91 a representation? No, absolutely not. And because this outlier is here, that's going to get rid of mean right away. So just understanding this problem, you would look at it, you would check your outlier. That's going to totally outweigh everything else and screw up the mean. You're going to get rid of your lows and your highs because that's not going to work. And that's where we see mode and range, and we're left with median as our answer. Okay. It's just being comfortable with reading these charts. Okay. Next problem, we have a scale drawing of a room is 8 centimeters wide and 12 centimeters long. The actual width of the room is 4 meters. What is the actual length of the room? So here's an interesting one, because if they're similar, right? The scalar is the actual width. Well, it's a scale drawing. A lot of us would say, okay, I've got width and length. So remember, we can always do what's called matchy-matchy. So I can do width over length. And if I did width over length, I've got 8 over 12. And then that should be equal to the width and the length of the actual. And the actual width is 4 over x. The problem is you have to catch this: centimeters, centimeters, meters. All right. So it's important that you keep them in the same unit of measurement, because if you don't, then you're just not doing it correctly, because likes go with likes. So we have to go ahead and change these out. Now, if we're doing centimeters to meters, I always want to go from the bigger unit down to the smaller unit. It just makes things easier. And when we do that, and it's been a while since I've shown you all this, but when I go from big unit to small unit, okay, so in this case, I'm going from meters, there's an M, meters to centimeters, then I will multiply. So from big to small, you always multiply. Well, what is the magic number for meters to centimeters. And there is 100 centimeters in 1 meter. So you multiply by 100. So if I have 4 meters, I would have 400 centimeters. The opposite is the same. If I need to go from centimeters to meter, I'm sorry. Yeah, that's right. Centimeters to meters, then I would do the opposite. So if I want to go from small to big, so centimeters to meters, then I divide. So it would be, I have 8 centimeters and then divide by 100. Well, that means I have, what is that, 0.8, just to make sure. 0.08. I've got 0.08 meters. Now, this is still right. I can still put 0.08 here and 0.12 here, and then I'd be able to figure it out. I don't like dealing with decimals. That's why I avoid that. I always try and go from big to small. You can work either one, but I don't like doing it that way because I get decimals, and I'm not a big fan of decimals. And I'm pretty sure you're not either. So with that being said, I know that before meters is going to end up as 400 centimeters. Now all of them are in the same unit of measure. We can go ahead and solve the problem. It's important that you put these in the correct unit of measure. Otherwise, if you do that matchy with 8/12 and the 4/x, you're going to get the wrong number. So what we have here is we end up with 8x and what is that, 4,800 divided by 8 divided by 8, x equal to 600. Now, you don't see 600 anywhere, but because, in my opinion, it's easier to deal with these whole numbers instead of the decimals, this is 600 centimeters. Well, you know that they're by the 100, so you either multiply or divide by 100. The only one that has 6 in it, right? Because that's the beauty of metric. It's a base 10 system, so whatever this first number is, it's never going to change. It's just the matter of zeros that are after it or before it, whatever. So 6 is the only one that makes sense here. 600 divided by 100 would give me my 6 meters anyways. So A is the correct answer. Okay. And then the other way of doing this is probably the most popular way. But again, when we're dealing with scale factors, I mean, that's what they're telling us what it is. A scale factor is the ratio. I always say that a scale factor is always how many times bigger or how many times smaller. So we either multiply by that certain number or we divide by a certain number. If they're telling me my scale drawing is 8/12, so if I do 8/12, which is my small over big, I get this here. And again, this is where I'm going to show you I don't like dealing with decimals. So it's 0.667. If I do 12/8, so I do large size over small size, I get, oops, sorry. Okay, 1.5. All this means is the room that I have, the scale drawing, the small side, the big side is bigger. Well, sorry, I don't want to confuse you. With 8/12, 8 being the small side, 8 is 0.667 of the big side. It's that many times smaller. 12 is 1.5 times bigger than 8. So the length is 1.5 times the width. Okay, because it's greater than 1. If it's less than 1, 8 is 0.667 times smaller than, or the amount of 12. I don't like this. That's correct, but I don't like it. I'm going to take this 1.5. So what you can do is you can say that the bigger one is 1.5 times smaller than the larger one. The scale drawing is 1.5 times either bigger or smaller. And this is how it works out. If my room is 4 meters, then I do 4 times the scale factor, which is 1.5. So I multiply by 1.5, and you'll end up with the 6, because they're proportional as far as them being a rectangle. Okay, that makes sense, because the 8 and the 12 represent the room. I've got 8 and I've got 12. So that if the one is 4, doesn't matter what it is, because the scale is universal. If you do it this way, doesn't matter if it's in feet, yards, inches, miles, whatever, because it's always going to be proportional to the rectangle. So see, I've got the 8 here and the 4 here and the 12 here. This is why, it's very difficult to do it with the ratio of 8 to 4 and 12, because they're different lengths. But by a scale factor, right? The scale factor is always 1.5. So I'm just going solely off of this. 8 times 1.5 is 12. 4 times 1.5 is 6. Okay. So 2 different ways of doing it. Again, I try and show you as many ways as possible that I can think of. You are the one that's going to decide which one works for your brain better. And that's what I want you to do. Do what you are most comfortable with doing. All right. Next one is, which shows 5032 in expanded notation. So this is expanded notation. It's just like scientific notation, but each one of these parentheses here, I'm just using this bottom one. Each one of these parentheses here represents basically a digit in this number. And I'm just going to show you real quick how it works out and a real quick way to do it. So if I have 5032, okay, then the way that the powers work is you should have zero. It starts with 0, 1, 2, 3. Okay. And I'll show you why. It doesn't matter what number it is. If it's 64th or 641,269, then always start 0, 1, 2, 3, 4, 5. So in order for expanded notation, I need to have all 5 of these. In this one, I've got to have, wherever there's a number, I have to have it. So I have a 0 because the 2 associates with it. I have a 3 or a 1 because the 3. I don't have a 2 because I've got a 0. So then I skip, and I know I have a 3 because there's a 5 there. Okay. Hopefully that makes sense, but you always start 0. You start from the furthest to the right number, start with 0 as the power, and then go right across. So I know with 5032, I'm going to have a 0, 1, and 3. If I look at my answer choices, I'll start here. I've got a 0, a 1, and a 3. So that works. For the second one, I have 1, 2, 3. That's not going to work because that doesn't associate with what I have. And then again, 1, 2, 4, not going to work. And then 0, 1, 4, not going to work either. Just by doing this, I've already figured out that A is the correct answer. Okay. So now let's just go ahead and truly figure it out, just so you can see why I was able to use that. And with a 5032, it basically breaks down to 5,000 plus, in this case, no hundreds, 30, and 2. So how can I make 5,000? Well, you take 5 and you multiply it by 10. How many times? You just count the zeros. 1, 2, 3, 5 times 10 to the third. So again, I can eliminate these right here because 5 times 10 to the third is 5,000. The zeros, right? It's just 0 times 10 to it would be the second, but we don't do that because it's just 0. So we leave it blank. 30 is 3 times 10, right? What's 3 times 10? 30. Doing it one time leaves us this. This is the one that's going to get everybody, or this is the one that confuses the most people. It's where the error occurs the most. 2 times 10. It has to be 2 times 10. But why do I put 0? Because anything to the 0 power, whether it's 10 to the 0 power, 50 to the 0 power, 64 to the 0 power, they all equal 1. So essentially it's 2 times 1, which is equal to 2. These are all equal to each other. This is what we refer to as expanded notation. So A is the correct answer there. More importantly, to just understand your exponent rules. Okay. Problem 5. We have Leonard finished 60% of his homework yesterday. Today, he finished 50% of what was left. What percent of his homework has Leonard finished? All right. So these can be, even though they're written so simply, they can be tricky because it's like, what's 60% of 50%? What's going on here? You just have to just follow it as you read it. So he finished 60% of his homework. Well, when you start something, you start with 100%. No matter what the value is, that value is equivalent to 100%. If you finish 60% of 100%, right? Well, just take it away. You finished 60% of it. So what's left over is 40%. Now it says today he finished 50% of what was left over. Well, what's left over? So we're going to bring this down here. We understand we have 40%. So again, this is 40% of something. So he finished 50%. Now, can I take 50% away from 40% like I did the first go around? No, I can't, because now we're doing percent of a percent, and that's something different. So that is not correct. We do not subtract this. But if we think about it, if I did 50% of something, then that means I've done half of it. Well, if I have 40%, I can just divide by 2 and I get 20%. So because would that make sense? 20% is half of 40%. What is that? 20%. Okay. So now that's the answer. It's 20% because half of 20. Or you can do it like this. The same thing. You're taking 50% of 40%. So go ahead and multiply it. 50%. Again, as a decimal, take your number 1, 2. I have 0.40 times 0.50. And what you get is 0.20, which is equivalent to 20%. Okay. Seems simple enough. Okay. Let me go ahead and check. Make sure there aren't any questions. Not seeing anything. Okay. Everybody's still with me. Comments, no. Okay. Still rocking and rolling. All right. Again, if you need anything, please comment. Oh, sorry, I'm just trying to get my screen back. Uh-oh. Okay. Sorry about that. Okay. Looks like everybody's good. Let's on to the next problem and let's finish the last half. Problem number 6 says, Sally built a storage box for a customer. Box was 30 inches long, 10 inches wide, and 20 inches high. The volume of the box was 6,000 cubic inches. Another customer wanted a box with the same width, height, but a volume of 8,000 cubic inches. How must Sally change the length in order to make the box? Looks like I got a question here. Why for problem 5, not 60 plus 50? 60 plus 50%. You can't, again, just because we're taking a percent of a percent. The question is why problem 5, not 60 plus 50? You've got the 60 plus 50 is 110. You can never have more than 100%. That's just not possible. And I know you'll say, oh, there's probably, I'm just saying in general, there's 100%. He had homework. If he had 10 problems, then 10 problems represent 100% of his homework. You can't have 11 problems, which is 110%, when there's only 10 problems. It's just, it's not relevant. So you have to say to yourself, out of the 100%, or the amount of problems, doesn't matter how many, but that amount is 100%, take 60% of that away. So you can just take it away. You're able to take it away because out of that whole. Now, when you take another 40%, or sorry, when you take another 50% away, you're taking a percent of a percent. So then, because you can't subtract anymore, it's another layer, it's another level. So now we're just multiplying. And so that's why you can't do that. Okay. Okay, hopefully that helps. All right, back to this one. When we're dealing with these boxes, geometry, anything like that, it's best to just draw a picture. So with our picture, we're going to create these boxes. Again, your drawings do not have to be pretty. They just have to get the point across. My first box was 30 inches long. So this is 30 here. They were 10. Oh, you know what? And again, honestly, it doesn't matter. We'll call this length. We'll call this 10 inches wide, and we'll call this 20 inches high. So you do length times width times height in order to get volume, and you end up with 6,000 cubic centimeters. Right? They even tell you that in the problem. So I know that volume is equal to 6,000. My next one is going to be very similar to the volume of the other one, same width and height. So width and height, if I have 10 width and I have 20 height, then I got to figure out what this one is, which is my length. The volume has to say it's equal to 8,000. So all I have to do is take, volume is equal to length times width times height. So if I have 8,000 is equal to 20 times 10 times, we'll call it X. So then I have 8,000 is equal to 200. X divide by 200, and I get 40. X equals 40. Now, make sure that when you're doing this, you've got to pay attention, because the question says, how must Sally change the length in order to make this box? Remember, we're using the same box, except we're changing the length, and we need to get that volume of 8,000. In order for that to be so, X equals 40. So I'm going to put this here, and I see that that is 40. This was the original. This is the new. Don't say you need to increase by 40. Then throw that in there. That's incorrect, because if you need 40 and you had 30, that means you need to increase by 10 inches. So don't get thrown by this question because you did all that work and you got 40 as an answer. But A is actually the correct answer. It has to be increased by 10 inches from 30 to get to 40. All right. Okay. Next one. Molly is playing a game with a friend. Each player rolls 2 6-sided number cubes. They always call dice number cubes, numbered from 1 to 6, and finds the sum of the numbers. And finds the sum of the numbers. Molly will win the game if she rolls a sum greater than 8. What is the probability that Molly will roll a sum greater than 8? Okay, so what you have here is, and by now, if you're taking these certification exams, you need to know about rolling dice. And 10, 20, last problem. Yes, you're right. Subtract 40 minus 30, you get 10. Yeah, you're correct. Okay, just sorry, there was a comment there. With the dice, all right, you've got this here. I know I don't draw it well, but 1, 2, 3, 4, 5, 6. There are 6 possible combinations on one dice. Well, when I add, because it says I'm rolling 2 dice now, right? I got a 6. You know, if you've played craps or any of that, you know, then you definitely know about probability. There's another 6 numbers because it says we roll 2 6-sided number cubes. So what is the probability, or what are all the possible outcomes when you roll 2 dice? Well, you have 6 chances here. You have 6 chances here. Anytime we're combining, doing combinations, well, there are 36 possibilities. So right away, I know that we're doing probability. The total amount that I have is going to be over 36. So because I have that, I need to figure out what greater than 8 would be. And so this is where, unless you know this in your head, or you're very attuned to rolling numbers on dice, it's just you gotta write it out. So in order to get a sum greater than 8, right? Greater than, not 8, but greater than 8. So with numbers 1 through 6, how can I make a number greater than 8? Well, the next number greater than 8 is a 9. So what is the combination I can use? Well, I know I can do, and I start with low numbers. So the lowest numbers I can use are 4 plus 5. So 4, 5 gives me 9. So now what would be next? Okay, so I can roll a 4. I can still roll a 4 and then get a 6. 4 and 6 is 10. And then those are all the combinations. I'm using the left side as 4. So with a 4 as my first number, I can always roll 4, 5, 4, 6. Then let's go up with a 5 as my first one. I can go, I've already got the 5, 4 here. I can go 5, 5, and then I can go 5, 6. Okay. And then the next one is 6. I can roll a 6 here and have the other one equal 6. And those are all the possible combinations on my first roll being 4, 5, or 6. Well, you have 2 dice. And if these are the only combinations that get me greater than 9, then what if the dice come out in the opposite order? So if I rolled a 4, 5 here, that means I can roll a 5, then a 4 here. If I roll a 4, 6 here, that means I can go 6, 4 here. And again, even though these are the same numbers, these are 2 different die. Just because I got 5 here and 5 here, you're like, oh, that's the same number. That doesn't count. There are 2 ways that you can roll 2 5s on when you're shooting dice. In this case, 2 6-sided die. So now go ahead and do 6, 5, and then do 6, 6. So with 2 dice, you have the possibility of doing 10 combinations. See that? Each one of these is a combination. So I have 10 total combinations out of 36 combinations that will give me a sum greater than 8. Reducing this down, just simplifying it, 2 is my common factor here. So 2 gets me 5 over 18. I can't do anything smaller than that. The probability that you have shooting greater than a 9 is 5 out of 18. So that's why if you ever, want to really understand playing craps and why it's the best game to win the most money, is because if you can play the odds and you understand how the probabilities work and the combinations work. This is what you need to understand. Okay. Okay, why is it 4, 5? 4, 5, and yeah, because each one of these dice you got to add. So the comment asks, why is it 4, 5 and 4, 6? Because you're finding all the different combinations. These are the combinations that are greater than 8. You can roll. Remember, you have 2 dice. So you have 1, 2, 3, 4, 5, and 6. You can roll 1, 2, 3, 4, 5, and 6 on the first die. And then you can roll 1, 2, 3, 4, 5, 6 on the second die. Then you can roll, those are 6 possible combinations. You can do 1, 1, 1, 1, 1, and then 2, 3, 4, 5, 6. Okay, if you really want to get into it, you can make all 36 combinations. You got to understand that we're only using the ones that are greater than 8. 4 plus 5 is greater than 8. 4 plus 6 is greater than 8. 5, 5, and so on. You can't have any other combinations that are greater than 8 because that's what it's asking you in. 3 and 6. Shoot, where was I? Oh my goodness. You know what I did? I saw 9 and I only saw that. Oh no. Okay. Shaniqua, thank you. You got me. I was solely focused on foot. Here's where my thinking was. Holy crap. Because I went 4, 4, and I did exactly what. So I did 4 and 4. Okay. And that's where I saw 8. So I said, oh, well, you got to go this. Shoot. All right. Good call. My bad. Let's see what happens there. Because you can do 3 and 6 and 6 and 3. So that's 2. 2 and 6. 2 plus 6 gives me 8. That won't work. 1 and 6, 1 and 7. Ah, man. Good call. Right? Because 3 and 6, you can roll a 3, you can roll a 6. Why is that not coming up? What else can I do that I don't have on here? 3, 6. 3, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, 36. That's not right. Uh-oh. What's going on with this problem? Number 1 through 6, find the sum of the numbers. Molly will win the game. She will a sum greater than 8. 6, 6, 5, 5, no, 4, 4, 5, 6, 3, 6, 6, 3. Ooh. You know what? I think this problem might. What about 3, 6? 3, 6 is greater than 8. Molly win the game. If she rolls a sum greater than 8, what is the probability that Molly will roll a sum greater than 8? I've got to put 3, 6. All right, this is live action. 6 and 3. So why is that not working? If we roll 1 through 6, sum of numbers, win the game, rolls greater than 8, we have 36. This right here, 3 and 6 is 9, 9, 10, 10, 11, 11. Same here. The next one would be 2, 6, 5, 3. That's crazy. Okay. My apologies on this one. Shaniqua, you got me, which is good. And it's always good because we can learn from our mistakes. I didn't even think of the 3, 6 because I was focused on what's greater than what makes 8. And I didn't think about that. I can't think of any other combinations unless something's wrong with the answer choices. We have 12 here, right? That makes sense. 1, 2, 3, 4, 5, 6. And then all of them the opposite way gives me another 6. So that's 12. When we reduce it, I get 1 out of 36. And so that would be it. So maybe that 11 over 36, when they did the answer choices, should have been the 1 over 36. So I'm going to call that the answer, but know that if you're watching this, that is incorrect. What was 7? 7, I had B as the answer. So my apologies for this one. So there's our learning moment. Make sure that you get all the combinations. My fault was starting with a 4 and 4 because I said 4 and 4 make 8. So I got to go higher. I didn't even think 3 and 6. So again, thank you for pointing that out. I apologize. I will try and change that on the answer sheet because there's an answer key at the end of this. So we're going to go with 1 out of 36 for this one. Again, just know how to do combinations for dice, okay? Because problems like these can be confusing. Okay, let's keep moving on. All right, problem number 8. We have a graph that city populations in 2005 and 2010. Here's our graph. Shows what the key is, 2005. Question asks, using the graph, which city had the greatest population change from 2005 to 2010? And so here's where I think you would get the most errors. Because it says the change from 2005 to 2010, a lot of people might choose this answer here because black is 2005 and white is 2010. And I see the distance between these two is less than the distance between these two. What about here to here? I think when it says the greatest population change can be you either increase or you decrease. So that's why I think a lot of people will write these two off right away. That's why I pulled this problem, because I wanted to just highlight that. When it says greatest population change, again, it just means the change. Change can be this many people left or this many people came in. And I think greatest population, we associate it with growth. So how did one go from small to big? So I want to just make sure that you're aware of that change just means that it's a change. It doesn't matter if it's people coming in or going, in this case with the city population. The number one thing you need to understand with all of your graphs and charts when you see these on these certification exams is what each of these lines represents. So this one is good because it gives it to you, and it's done by 0 to 200. So I got 200. Each line is 200, which means if I fall anywhere in the middle, because see how there's some that aren't really there. So this would be 300 because it's equidistant. From 200 to 400, the middle would be 300. So I got 200, 300, 400, 500 here, 600, and so on. So that's how your y-axis is labeled. So greatest change, each one of these blocks is worth 200, right? 200. So what I want to look for in my change from one bar to the other, it doesn't have to be how far down is black than it is from the white one. So I see here that this is less than, right? That's 200. This falls less than 200. Right away, this one is 200. This one's 200. And the gap here is way more than 200. So I can get rid of this one here. I would cross out this alta, right? Because each one of these has at least one full horizontal bar. Does that make sense? Like one chunk, a 200 chunk. Next, I need to go which has it greater than a bar. So this one is just over, this one is just over, and this one is way over, right? So from one bar to the next, one bar to the next, wrong side. One bar to the next. I've got this little space here, this little space here, and from one bar, I've got this big space here. So these two are kind of similar, right? But they definitely don't compare to this amount here. And so that's why I choose delta, because the greatest population change occurs where they went from, let's just estimate it here. Let's call this, let's call it 900 and I don't know, just to be, let's call it 975. And then it went down to, let's call it 500. Oh gosh, 590-ish. Okay, because it's just below 600. Right? That is definitely a greater change than what these two went through. And so that's why delta is going to be your change. And it's also the opposite. It went down. Even though it went down, it dropped almost 400 people. It was the biggest population change. It was a decrease of 400 instead of an increase. Okay. Yeah, because of the fact that you're going down. Down is still a population change. Up is still a population change. It didn't say which one had the greatest increase. Okay. If it said greatest, and then I'm going to put this down here, increase in population, then I would choose B, right? Doesn't that make sense? If I increase the population, then yeah, going from whatever 475 up to 800, that was a population increase. And that's not the case. So that's why I picked this one, because you're thinking greatest as this. So here's why. So here's what, let's just say it was 975 and 590. 975 minus 590. So this one is 385, right? 385 people. Doesn't matter if they came or went, it was 385 people. With this one, I'm going to call it 600 minus, I'll kind of put that just above the middle. So 300, let's call it like 310, 600 minus 310. And this one is 290. And then for this one, it's 800. And then let's call it 575. So 800 minus 575, and I get 225. So now look, which one had the greatest population change? What's the bigger number? 225, 290, or 385? 385 is the greatest number, and that's what you're looking for. Don't be fooled by the greatest meaning increase. If it said greatest population increase or greatest population decrease, then you're talking about something different. But these words are not in here, right? Decrease or increase. That means you're more specific. Okay. And that's the reason why I chose this problem. All right. Next one. I've got 3 different flavors of fruit juice in a cooler. There's the same number of bottles of apple juice as bottles of grapefruit juice. There are 4 more bottles of orange juice than the other kinds of juice combined. There's a total of 60 bottles of juice. How many bottles of orange juice are in the cooler? This is a problem that you would see at all levels of testing. It's wordy, it's kind of confusing, and you're kind of like, huh, what are you talking about? More than double and 4 more than that. So you just gotta stay with it. So let's kind of walk through it. There are 3 different flavors of fruit juice. There's the same number of apple and grapefruit. So if I have the same number of apple and grapefruit, then I can keep them as the same variable. Makes sense? Then it says there are 4 more bottles of orange juice than the other kinds of juice combined. So it's crazy, right? So this is, let's call this apple juice. Let's call this grapefruit juice. And then our orange juice is going to be, because we're going to add this together, it's going to be 4 more. I'll put it in parentheses for you. 4 more bottles of orange juice than the other kinds of juice combined. Well, if I have apple juice and grapefruit, which are the same, then I would do both of them more than them combined. What do you do to combine them? You take X plus X, just like that. Now it sounds crazy, right? So that ends up being what we have. And these are all equal to 60. Okay. So I hope that's not too confusing. And that's why they make these problems like this, was why, that's why I didn't use A for apple and G for grapefruit and then O for orange juice, because then I have 3 different variables and I can't solve it with 3 different variables. And again, that's why they designed this problem like this, because I can use the same variable, because it said the same number of apple and grapefruit. So keep them the same variable. Then it says orange juice is the same number of apple and grapefruit combined. So again, here's my apple and grapefruit, and then, but there's 4 more. So that's where I got that value there. So now just go ahead and solve it. The parentheses are there just to show you that that's what orange juice represents. So I can take the parentheses away because I'm not distributing anything. So how many X's do I have? I have 4 X's plus 4 equal to 60. Subtract 4, and I get 4X is equal to 56. Divide by 4. X is equal to 14. So I look at A and I see 14 and I'm like, oh, okay, I solved it. Again, you got to make sure you're answering the question that they're asking. It says, how many bottles of orange juice are in the cooler? 14 represents your variable X. X represents apple juice, grapefruit juice. It does not represent orange juice. Orange juice is this here. So now what we have to do is, hopefully you've seen that we've solved that. X is equal to 14. Let me make some room. So X equal to 14. Here's my orange juice. So let's do 4 plus 14 plus 14, and we will get 32. There are 32 bottles of orange juice based off of this scenario here. So kind of a wordy problem. When you read it at first, probably like, oh, this isn't too bad. And then you finish it and you're like, oh, what? And then to understand how to get it, just know that they can't give you 3 different variables, or you can't use 3 different variables, because the amount of variables you have is the amount of equations you need to solve it. 1 variable, you need 1 equation. 2 variables, you need 2 equations. 3 variables, 3 equations, so on and so forth. Okay. All right. Last one. Little bit of geometry to finish it off. 2 isosceles triangles are shown below. The measure of angle U is 50. What is the sum of the measures of angle T and angle R? Okay, I need to find angle T and I need to find angle R. If I'm doing this, again, I need to draw these triangles like this. It doesn't matter how pretty they are, but as long as they have the markings, okay? And then this one here, okay, markings here. What are these markings? They are congruent signs. It means that this side is the same length as this side, and these 2 are the same as these 2. It gives me angle U. U here is 50. And so what do you know about isosceles triangles? 2 sides are the same, which means 2 base angles are the same. That means this angle is the same as this angle, and this angle is the same as this angle. Let's start with this one. If I always have 180 degrees in my triangle, and then I take 50 away for angle U, I'm left with 130 degrees. Because I have two equal angles, just divide by 2 and we get 65. So that means this angle is 65 and this angle is 65. This is angle T. And so that's the one I need. Remember, we want the sum. And then we've got this sign here. This is a right angle, which means it's 90 degrees. Do the same thing. I always have 180 degrees in my triangle. If I can write that nice and neat. I've got 180 in my triangle. I take 90 away. I'm left with 90 degrees. Divide by 2. I have 45-degree angles. Looking for R, that would be this one right here. I've got 45. I've got 65. 45 plus 65 gives me 110. And C is my answer. All 90-degree angles, right? All right angles. Nope, stop. I shouldn't say that. Right angles that are isosceles. That's the big one. Sorry. All right isosceles are 45, 45, 90s. This one is whatever the angle is, find the base angles. They're both the same. Just know that 180 degrees in a triangle, isosceles are two sides, two base angles the same. That's pretty much it. Okay. All right. My apologies for the dice. That was problem number 7. Again, make sure that 3 and that 6, that's on me. I apologize for that. We're going to call D the answer. We're going to say that they screwed up, but I'll take the hit on that. And thank you, Shaniqua, for doing that for me. So I'm going to put a little star by, oops, that's not 8, it's number 7. By number 7 there. Okay. But other than that, that's going to be it. Again, if you have any questions, please feel free to contact us, info@kathleenjasper.com. Send me your problems, send me your questions, send me anything, and I'll be happy to go ahead and look over it for you. Are these triangles measure 90 degrees to get one? Why do you have to divide by 2? Okay, question is, why do I divide by 2? You divide by 2 because your base angles are exactly the same. So whatever you figure out is this angle here. You have some value. In this case, they gave us 50, and then we know that that's 90. We have to distribute the remaining degrees to these base angles here. Because it's an isosceles, both angles are the same. So it's just like saying, I've got angle, so just for this triangle, angle U is 50 degrees plus an angle plus an angle. Both those angles are exactly the same. And then it has to always equal 180 degrees. Well, that gets you 50 plus 2x equals 180. You take away the 50, you divide by 2. That's where you're dividing by 2 there. You always divide by 2 because you are getting them 2 equal angles. Okay. To get the 110, the question asks, I'm starting to get a little crazy here. The question itself asks the sum of the measures of angle T and R. So you've got to, so for your question there, what is the sum of T and R? You found T, you found R, 45 plus 65. That's where you get the 110. Okay, Shaniqua, are all your live videos available on YouTube? Yes, all the videos are live. So once I'm done here, give it a few minutes to a half hour, and then it will upload. Not just go into our YouTube, it's Kathleen Jasper, and then search for weekly math videos, and you will find the entire list of our live sessions. Okay, so there we go there. Let me just double check. All of these were on the YouTube. Let me, anybody on the FB? Okay. Nope. All right. Okay. That's it. Another session in the books. So again, for all of you, I hope that helped. I'm here every Tuesday. Send me your questions, send me your problems. I'm happy to help in any way that I can. I understand that math can be a weakness for a lot of people, but we will get through it. And I hope you get all of your certifications signed up, ready to go, get it out of the way, have a great new school year. With that being said, I'll be here every Tuesday for you from 5 to 6 p.m. If you need anything, let me know. But other than that, I will see you next